Hello there, my name is Bradley Steinfeld, and this is the beginning of lab number 3, covering pig, hive, and jackal. To begin with, we're going to talk about pig. So to begin, let's open up the terminal and look at the data file, the input file we're going to be using. So to look at the first 5 lines, let's do a head-5, and we're going to be using the googlebooks.csv input file. And pretty much this just is a word count from 1988 Google Books on how many times these words occurred. So the first column is the token or word we're looking for. The second column is the year, so it's always going to be 1988. The third column is how many times that word occurred in all books overall. The next column is how many pages that word occurred in. And the last column is how many books that word occurred in. So for example, with the last row, 0.003, it occurred 4 times overall, on 4 different pages, and in 2 different books. Okay, now we need to put this file onto our Hadoop file system with a Hadoop fs put command. And now let's put it into a file called googlebooks1988.csv. Okay, now let's start up pig. So to do so, just type pig, and you know you're in when you see a nice prompt of grunt. So what we're going to do is we're going to use a pig UDF to compute the length of each word. However, this UDF is located inside the piggybank.jar file, and we need to use the register command in order to load this jar file. So let's type register followed by the piggyback.jar. So the first step to actually process the data, we need to load it. And in order to load the data, we need to use the load command. So for instance, here we're setting records to load the googlebooks.csv. And then you'll notice that the following arguments in the brackets actually correspond to the columns of the data I gave you before. So the word, the year, the word count in total, how many times it occurred in the page, and the book count. You'll notice that this command actually returns instantly because no processing has occurred yet. The processing is actually delayed until you use the dump command. So now in order to actually produce a histogram, we want to group by the length of the word. So we do so by using the group command and setting it to a grouped variable. Finally, we can actually sum the word counts for each word length using the sum function with the forEachGenerate command. We can do so just like this. And as I mentioned before, if we use the dump command and pass final, we can actually produce output and actually run all the processing we need to do. And once the processing finishes, you'll see the output, which should look something like this. So you'll notice the left side of each of these pairs is the length of the word, and the right side should count how many times that word occurred. So you'll notice lower numbers occurred significantly more, while higher numbers only occurred a few times, or once in some of these examples. Anyways, to finish, let's just quit pig. You do so simply by using the quit command. Great. Now let's clear the screen and move on to Hive. What Hive is it pretty much introduces a very simple SQL-like query language called QL. So to begin, let's get into Hive using the Hive keyword. Rather than something clever like sting or bee, the prompt for Hive is actually just Hive itself, and when you see it, you know that you're ready to go. For our first step, we're going to create a table called word list, and this is going to use the same input file that we used previously. So let's create a table with columns for the word, the year, the word count, page count, and book count. We do so with something that looks very much like SQL. You can see it's just a create table called word list, pass in each of the columns, and then show how the fields are delimited by a tab. Okay, when you see the OK in the time, that means the command ran successfully. So now in order to load the data, and we're going to use the exact same Google Books CSV file, we'll use the following load data command. You should note that unlike Pig, this is actually going to be loading the data from our local file system. We can see that it copied correctly, loaded the data into the table word list, and went successfully. So now let's do the exact same thing that we just did with our Pig example. So what we're going to want to do first is we're going to want to create a table called word lengths, which is going to store the counts for each word for our histogram. So let's first create this table with a simple command. Just a simple create table command, creating a table called word lengths with two columns, a word length and a word count, which are both integers. Now let's fill this table with word length data from the word list table calculated using the length function. So this just looks something like this. So this pretty much selects the length of the word column from the word list table and saves it into the word length table. So when we run this, you'll actually notice that it's actually running map and reduce jobs. So after this finishes, we just have one more job to run. So to do the final step, let's actually issue the following command to select the word length and the sum of the word count from the word lengths, and let's actually group it by word length. This pretty much should give us the exact same result which we got from Pig. Once again, by entering this command, it will run another map reduce job. After the command runs, some of the numbers might look familiar, and similar to above, we notice that the lower numbers are generally higher count. And if I actually scroll, we can see that 1 has 122 something something 611. If I go down, we can see 1 is 122 something something 611, and thus the two outputs are exactly the same. So to finish, let's exit Hive. With the quit keyword, you need a semicolon. Beautiful. And now let's clear the screen and get ready to start working with Jackal. Okay, to begin working with Jackal, we're going to first use a different input file, and it's in the exact same location, except it's called googlebooks1988.del. So do a head-5 to see what it looks like, and it's just comma separate, it's just a different format. And now let's put this file into HDFS by doing a Hadoop fs-put from Data University input googlebooks.del into a file called googlebooks1988.del. Okay, and you can check with an ls on the user root directory, and we can see that our googlebooks.del is there. Okay, so now let's get into our Jackal shell, and to do so, just type Jackal shell -c. And once it's initialized, you should be within the Jackal shell and you can start issuing Jackal commands. The first thing we're going to want to do is just read in this input file, the googlebooks.del. So to do so, we're going to create a variable called wordList and read in the googlebooks.del, and we specify it's a del file. And we specify the schema, which is going to be a word, which is going to be the string, followed by the year, which is a long, a word count, which is a long, and then the page count and book count, which corresponds exactly to the format above, which is the same as that we did in the other labs. So enter the following command and press enter. And now the word list variable should be loaded with the data from Google Books 1988. One thing to note is that Jackal is just a simple query language based on JavaScript, or that's JavaScript-like. So you'll notice from here on out, all of the syntax and the grammar is going to be in JavaScript form. Okay, so what we're going to do now is we're going to create a word lengths variable, which just counts the lengths of each of the words and stores it in a different schema. So we're going to create a word length variable, which is just going to be a transformation in our current word list, which is going to simplify from all that other information and just keep the length of the word and the count associated with it. To do so, we're going to use the strlen function, so string length, on our word, and then also store our word count variable. So now there's only one thing we really need to do left in order to actually create a histogram which groups all of the words by word length and counts. In order to do so, we're going to issue the following command, which groups all the words by their word length and then also stores the sum of how many times that count exists. So it adds up all of those counts. Anyways, when I issue the command, it actually goes through and has to run this query, so it will take a little bit of time.